Welcome to Reconstructing Gravity. I'm Ted Cole, and this is chapter G19, in which I'm going to do a summary of this entire gravity video series, trying to improve our concept of how does gravity work physically. To get the whole picture, you should really watch my series called Reconstructing Relativity, which was part 1. It gives a physical explanation of special relativity based on a constructive model. So we have a physical understanding which isn't normally presented by other people who explain how relativity works. In the Reconstructing Relativity series, I postulated that all particles of mass, are nothing more than energy that's trapped in a repeating harmonic cyclic pattern of motion. And we learned that the faster a particle of mass travels through space, the slower its cycle time is, and the shorter its length in its direction of motion becomes. We also looked at the Michelson-Morley experiment, which was an attempt to measure the speed of Earth passing through space. And this was what they expected to happen. The light in two directions, one upstream and downstream through the motion of space. They measured the time difference. They expected a time difference in the arrival times of light sent in those two directions. But this is what actually happened. Regardless of the direction or the speed of Earth through space, the light from the two directions always returned at the same time. And it happened because of the length shortening of the instruments and the clock rate slowing of everything in the moving planet clock, including the clocks in the laboratory. The important takeaway is that because of this length shortening and clock slowing, the round-trip speed of light is always measured to be the same, regardless of the direction or the speed of motion through space. In 1905, there was no constructive model because they didn't understand enough about the nature of matter. But Einstein realized that if you can't tell your speed through space, even though the round-trip speed of light is the same, always, you can't tell if the light's actually taking more time going in one direction than the other, or if it's taking the same amount of time. You can't tell what the split is of those two halves of the round trip. So, needing to be able to synchronize clocks in order to make any measurements at all, Einstein said the most logical approach is to synchronize clocks such that the speed of light in one direction will always be measured to be the same. Even though that might not be true, here's the quote: "That light requires the same time to travel the distance from A to M as from B to M is in reality neither a supposition nor a hypothesis about the nature of light, but a stipulation which I can make of my own free will in order to arrive at a definition of simultaneity." This means that synchronized clocks in scientific reference frames that are actually moving through space will not truly read the same time at the same time. If you could freeze the universe, you'd see that they were reading different times at that same instant. And this is a phenomenon I call time skewing. Time skewing appears in the Lorentz transformation equation as that Vx over c squared term. In other words, it's proportional to the speed through space, v, and the distance from a reference location, x. What does all this have to do with gravity? Well, time skewing really opened the door to a physical model of gravity. We start with two facts. Speed through space slows time. That means for everything, for biological systems and mechanical systems, including clocks. And the second fact is gravity also slows time. The stronger the gravitational field, slower time passes for, again, everything, biological systems and mechanical systems, including clocks. Suppose we have a rocket ship that's accelerating in space, and it feels exactly like gravity on Earth. It's got a constant acceleration, always speeding up. Well, we know if we had two clocks, one at the front and the rear of this ship, they would always be traveling at the same speed through space, so they'd always be running at the same rate as each other. However, because of their separation, their time skewing would be steadily increasing as the velocity grows. And this means that in the scientific reference frame sense, the forward clock would always be measured to be running faster than the rearward clock. Now, the amount of rate difference on these clocks depends on the distance of their separation, but with an Earth equivalent gravity, the amount of time skewing, the rate difference in these two clocks would be 1.0926 times 10 to the minus 13 seconds per second. But how does gravity slow clock rates? We know that valley clocks run slower than mountain clocks, and we know that clocks on Earth run slower than GPS satellite clocks. Could it be that space flows towards Earth, speeding up as it approaches Earth? This would slow clocks at lower altitudes more than clocks at upper altitudes. The escape velocity of a large mass like a planet or star is the velocity a falling mass would have if it fell from an infinite height. Could space itself be falling at this same rate? So the amazing thing is, if we plug into this escape velocity formula for Earth, and we put in 1,000 meters elevation difference, and we look at the time slowdowns at these two elevations, we're finding the same exact time rate difference that we got previously in the rocket ship calculation that used time skewing. The precise agreement between these two simple yet very different calculations provides an amazingly simple hypothesis. The effects of gravity are caused by the motion of space towards masses at the escape velocity of that mass. This hypothesis leads quickly to some serious questions about how this type of motion of space is possible. I'll be addressing those questions later in this video, but first I'll test this hypothesis with many other gravity calculations. First, the simple case of dropping a ball near the Earth's surface. Why does the ball accelerate downwards? Remember, we're hypothesizing that the velocity of space increases at lower altitudes. So although it's quite subtle, there's a difference in the speed of space on the upper half of the ball and the lower half of the ball. This makes the cycle time of energy in the lower half of the ball longer than the cycle time in the upper part of the ball. So we go back to our special relativity physical constructive model for what is a mass, and we look at how the motion of space would affect that. And what we see is that since the energy takes longer to cycle in the lower half of the mass than the upper half of the mass, the energy doesn't quite return to the same point it started. It returns to a point a little bit lower than the center point. And on repeated cycles, this leads to an increasing acceleration downwards. You'll have to go back to my ball drop video for full details, but the bottom line is this calculation does give the correct acceleration of a falling ball in Earth's gravitational field if the velocity function of space is the escape velocity of Earth. We then ask the question, why does a ball sitting on the ground not drop? Which sounds like a dumb question, but it's actually really important. The reason a ball that's sitting still on the ground doesn't drop is because there's pressure underneath, which causes a pressure gradient and therefore a strain gradient to run through the entire body. This makes every particle in the body have a shorter lower half than the upper half. And this shortening of the lower half relative to the upper half counters the effect of the increased space velocity, such that the energy cycling in the upper and lower halves both return to the original point where they started. And I think this very neatly explains the reason for the equivalence or proportionality of gravitational mass and inertial mass. They're related because there's a physical reason that they're related. Next, I looked briefly at black holes and noticed that the escape velocity of a black hole is the speed of light c. Well, great. That makes perfect sense with my model, right? If space is constantly increasing its velocity towards a mass, well, when that velocity gets up to the speed of light, that's exactly the place where light can't get out, because light travels at the speed c through space. So perfect. But in 2013, Wikipedia, they said that fact, but they said that this equivalence, that this fact is just a good way to remember the Schwarzschild radius. It doesn't imply that it has any physical meaning. It's not a valid way to derive it. It's just a coincidence, which I thought was really funny. Then I looked back several years after that, and that statement that it was a coincidence was gone. And if you look now in 2023, it doesn't say it exactly the same way at all. It just says, well, when you get close to a black hole, space-time is warped so much that no particles can escape, and it doesn't even talk about light not being able to escape, although obviously that's why it's black and no light can escape from it. So real interesting short little video on that if you want to check it out. Next, I did calculations on starlight bending. Now this was a thing that Einstein predicted. It made him famous. It confirmed his general relativity theory of gravity. But it involved a very complex analytic math, Riemannian curve geometry math. But what I did was use my model and simple, normal Euclidean geometry and a time-step approximation calculation. So again, my model basically looks like this. It's saying that space itself is moving in towards a mass following escape velocity function, getting faster as it approaches the mass. So the question is, how will this motion of space affect light that's passing through this space? What matters is the direction that the wavefront of light from the stars approaches the camera lens. This picture here is an overlay of during the eclipse when the light was passing nearby the sun, and overlaid with another time when the sun was not there. So you can see that dislocation, the double image is bent light and not bent light. So that's the question, is how much is the angle that the light approaches the camera, how much does it change because of the gravity of the sun? Again, you'll have to see my whole video for more details, but in brief, the time-step calculation I did provided for rotation of this wavefront due to several effects. Some were evident farther from the sun, and others were strong only when close to the sun, causing rotation due to different rates of speed of space, slowing the forward progress of the wavefront more near the sun than farther away from the sun. This is an overall very exaggerated, compressed space scale picture of how the light curved, and this final graph is the end result, showing that closer passing distances, passing closer to the sun, the effect was stronger, and the result I got close to the sun was very close to Einstein's result, which was the correct prediction for the measured starlight bending. And the last of these gravity calculations I did was a Shapiro delay confirmation. This was an experiment that was also done to confirm Einstein's general relativity theory. And the idea was to bounce a radio signal off of Venus, which takes a certain unknowable time to return. But as Venus comes close to passing behind the sun, the gravity of the sun slows down the time of this return signal. This was similar to my starlight bending calculation. It was a time-step numerical approach, and this was actually simpler than the light bending. Here, the emphasis is not on the direction of the wavefront, but it's about the time of progress of the signal. So as the signal comes from Earth towards the sun, it will because of the motion of space, it will go a little faster. And then once past the sun, it will be retarded somewhat. And then coming back, the same thing will happen the other way. But when passing close by the sun, the progress of the signal is slowed because of the transverse speed of space in the vicinity of the sun. And here again, my numerical time step calculation did really well. As you can see in this graph, the closer the passing distance is to the sun, the time delay increases to about 0.0002 seconds, which is just what Wikipedia says the correct result is for this experiment. There's definitely more to discuss about how this model works, but let's take a quick look back at all the successes that we've just gone through for this. Remember, the hypothesis is that space is a physical entity that transmits energy at the speed of light, and that this space moves towards large masses at the escape velocity of those masses. And with this hypothesis, we've correctly calculated gravitational time dilation, correctly found the acceleration of drop masses in a gravity field, explained why gravitational mass and inertial mass are always proportional, found that the black hole escape velocity is equal to c, which is perfectly supports this idea of this model. And finally, we did some numerical time step simulation calculations on starlight bending due to gravity and Shapiro time delay due to gravity, and found that both of these worked out extremely well, and those just used simple geometry, no fancy curved Riemann geometry, just simple Euclidean geometry, and got very good results for those two calculations. So what more is there to discuss, right? The model works. It's great. But now, as I said, if this purports to be a physical explanation of gravity, we need to discuss this issue of space flow. How and why? And this section of discussing space flow will admittedly be more speculative, but I thought about this at great length, and it's only right that I share my thoughts. If space flows towards masses, where does it go? Does it disappear? And what's the root cause of this flow? And aside from the problems of where it goes and why it flows, this escape velocity function isn't a normal flow velocity, because if we have space flowing towards a sphere, the area of the sphere is proportional to r squared, the radius of the sphere. And so one would expect, if it was, for example, water flowing towards a central drain hole, we'd expect the velocity to be proportional to 1 over r squared, because the velocity as the area decreases, the velocity increases proportionally. Instead, what we're proposing here is that the space flows at the escape velocity, which is the square root of 2gm over r. G is Newton's gravitational constant, m is the mass of the planet. And escape velocity is proportional to 1 over the square root of r. And these two functions, proportional to 1 over square root of r and 1 over r squared, give very different flow speeds. With the standard flow model, the speed of space should diminish very quickly as you go to larger distances from Earth. But with the escape velocity function, the speed of space drops off much more slowly. You should check out my full videos on this, but essentially I found that somehow the flow rate must decrease in order to elevate the flow velocity. And with calculus, I showed that for the escape velocity profile to be true, the flow rate decrease with time had to be a constant, 12 pi gm. Again, g is Newton's gravitational constant, m is the mass of the planet. So essentially, this flow rate decrease depended only on the mass of the planet. Then I showed a little thought experiment I did, and this was very similar to what Einstein had done, only he applied it to his space-time model instead of a physical model. I imagined test particles in free fall placed in a spaceship in the form of a cube, and then as the whole ship and the balls inside it drop, the balls will get closer together horizontally because they're falling in radial lines towards the center of the Earth, but they'll separate vertically because the lower balls have a stronger attraction to the Earth. And so if falling with space, not through it, but falling with space at the escape velocity, the volume of this shape, imagine no space would flow through any wall of this cube, but the cube would get smaller in volume as it dropped. And this dropping cube is representative of the volume lost by each shell of space in equal intervals of time as they fall towards the planet. And during the analysis on this volume loss, the derivative of the flow rate confirmed, the calculation confirmed that what calculus had told me, that the flow rate dt is 12 pi gm. Along with this, we get to make the interesting observation that the units of Newton's gravitational constant, which always seemed arbitrary to me in the past, cubic meters per second per kilogram, now actually makes sense in terms of this model as cubic meters per second per kilogram. That totally matches what this model is saying. There's a flow rate loss that depends on the mass of the planet. Delaying further the question of why, I sought to provide an answer to how space can diminish in volume in this way. To do this, I proposed a new physical structure for space on its finest scale, which I assume is the Planck scale. I proposed that on the finest scale, space is a mesh network of tetrahedral form, but it turns out you can't fill space with just tetrahedra. But if you stack tetrahedra in the closest form, which can extend indefinitely, you find that it looks like this. This is 4 tetrahedra stacked, and you'll notice that in the center, between the 4 tetrahedra, there's another shape, which is an octahedron. And if you compare the geometric volumes of the tetrahedron and the octahedron, you find that the octahedron has 4 times the volume of the tetrahedron. So what this means is if space was entirely filled with this tetrahedral, octahedral structure, there would be 4 times as many tetrahedrons, but the octahedrons would be 4 times as large. So the volume inside each would be equal. The total volume of space would be half and half, tetrahedrons and octahedrons. So I conceived of this flow model in which the octahedron tetrahedron mesh flows towards masses, but as it does, the tetrahedrons break down, creating more octahedrons which flow outwards, and this can completely resolve the flow issue of where does the space go. If only the tetrahedrons provide the active network that transmits light, but the octahedron is completely a inert true void, then we can have the active tetrahedral mesh sliding towards planets at the escape velocity while being converted to inert octahedrons which are flowing outwards, always maintaining the same volume ratio, the equal volume ratio at every position. This light space, dark space model also provides a possible reason for the expansion of the universe. If masses like stars and black holes are machines that convert light space to dark space, then new light space must be created somewhere in the universe to maintain that volumetric balance of the structure. Now I'm going to compress my most intensive analytical work into the shortest possible summary to address the question of why. What drives space to flow into masses? The answers lie clearly inside the mass. The first step was computing the escape velocity inside a mass. In other words, imagine letting a mass drop from an infinite distance not only to the surface of the planet, but inside a small hole and all the way to the center of the planet. What would the velocity be all the way in? And this is the graphed result of that calculation. The first step was taking this internal velocity and computing dFlowrate dt, which looks like this, and then breaking this into presumably two separate terms, one similar to what was happening externally, internally, and then the remainder would be this yellow function shown here. Then I had to try to figure out what caused that, and through a circuitous process, I came to find that that function was a function of internal pressure of the planet. Analytically, this meant that while I had computed the dFlowrate dt internal to be the upper equation, which did not include pressure, by computing what the internal pressure was and examining the equation, I could re-express that internal dFlowrate dt such that it did include pressure as one of the terms as shown in the bottom equation. This didn't directly explain why gravity, but it gave a strong clue. Pressure was important. When had I looked at pressure before? Oh yeah, pressure caused a strain gradient that prevented masses from falling. But every bit of mass in a planet is non-falling. When I'd looked at this before, I was able to assume linearity of pressure and strain over a very short distance for a particle sitting on the surface of the Earth. But now I was considering a situation where the pressure could not be considered linear. Pressure is the green curve in this graph. We saw before that a pressure gradient produced a strain gradient that caused the lower part of the mass to be shorter than the upper part of the mass, which caused the energy cycle times to be equal in the upper and lower parts of the mass when sitting in a gravitational field. But if the energy cycle times are the same in the upper half and the lower half of A, and the lower half of A is the same as the upper half of B, and the cycle times have to be the same in the upper part of B and the lower part of B, and similarly upper part of C and lower part of C, what that means is every unit of mass, every chunk of matter in the whole planet has to have the same cycle times in the upper part and the lower part. And the strain, the changing pressure causing changing strains, has to guarantee that all the way in from the surface to the center of the planet. And when I charted it all out, it all was true. The space velocity, which I'd computed, produced a variable gamma from the inside of the planet to the outside of the planet. And the pressure, which I'd also computed, which was variable, nonlinear, from the inside to the outside of the planet. At every point, at every radius, the pressure created a strain which exactly matched what it needed to be to cancel the gamma. And it turned out the speed of light is involved in this because the speed of light is what creates that velocity gamma. This was the eureka moment, the solution. Space must internally flow at the rate required to create a gamma which balances the strain produced by the cumulative pressure which the same gravity creates. Every particle of mass within the planet has the same cycle time. What that large table showed was that the ratio of pressure to strain is equal to the density of the planet times c squared. And if you look at the units of pressure, it becomes energy density equals mass density times c squared, or E equals mc squared. I had a video called Why is there gravity at all? Gravity seems to be a response to itself in a way. It produces the space flow, which produces the pressure, which the flow creates the gamma. But why not a trivial solution? Why not no pressure, no flow, no gamma? Why is there gravity? My best guess for this is that masses and planets and stars co-evolve with gravity. Random collisions of masses in space always produce a compression. And with compression comes an internal pressure gradient. So maybe if there's a field of masses floating around in space randomly colliding with each other, maybe every time there's a collision, there's a compression, there's an internal pressure gradient which creates a transient microgravity, which causes a flow of space surrounding that collision, always towards it. This would eventually lead to a gathering of masses together and a situation where collisions were continuously happening more frequently until they were essentially perpetual collisions, which could end up in a perpetual compression situation. And then after that started, the surrounding particles would be continually drawn to it and add to the mass of the particle and increase the gravity of that mass. I also did some very rough calculations on the expansion of the universe based on my model as I described earlier. But the results varied quite widely depending on assumptions made. However, my results provided some plausibility to the idea. All right, time to end this one. This is my longest video ever by far. Thanks a lot for watching. Please remember to like and subscribe. At the left is my book on special relativity you can find on Amazon. I've also started a new playlist on the topic of truth. You can check that out on my YouTube webpage. And I'll pick some music and catch you next time, one place or the other. Bye.
Walking through a wonderland, I got you by the hand. Every move we made, just as if it were planned. 3 roses were born with you in mind. 3 roses were born with you in mind. I've got to stop and see what I'm on about. Stop and feel what